I think the general way we're viewing it is that there's no clear dividing line between attentional systems and memory systems, but they have to be fundamentally interactive, and that attention can shape what your memory systems are doing and how they're doing that. And these memory systems can also then affect what you're paying attention to and affect different attentional systems. So I think that the cognitive labels of memory and attention are very useful because they are convenient shorthands that we all intuitively understand and can communicate, and also allow us to communicate our science to the public.
This is Brain Inspired.
Hey everyone, I am Paul. My guest today, Mariam Aly, runs the Aly Lab at Columbia University. So in the last few episodes of Brain Inspired, we've focused a lot on the interactive nature of our brains and our cognition. So for example, recently on Collins, talked about how working memory interacts with our reinforcement learning systems during learning. And with Michael Anderson and Luis Pessoa, we've discussed how the traditional way of studying brains in terms of individual areas and studying cognitive functions as if they were individual modules functioning independently, that's likely not the best way to study brains and minds. And instead, we should honor the complexity and interactions and integrations of brain areas and cognitive functions. Today's episode continues in that vein. Mariam and her lab focus on the interactions between memory, attention, and perception. And although much of her work and much of our discussion today focuses on one brain area, the hippocampus, she shares the view that it's wrong to think of a single brain area as carrying out a single cognitive function, which we also discuss. The short story is that memory affects our perceptions, attention affects our memories, and memories affect our attention. And these effects have signatures in neural activity measurements in places like the hippocampus and other areas. And Mariam details these stories more during the episode. And toward the end of the episode, we go pretty deep into Mariam's personal story and career trajectory. She had a pretty challenging stretch in graduate school regarding anxiety and overworking that I think many of you may be able to relate to. She was very open about her experiences, and hopefully her story will help any of you who might be struggling with similar challenges. So I appreciate Mariam being so open with that. Show notes are at braininspired.co/podcast/156, where you can also learn how to support the show through Patreon, and I would love to have you join our Brain Inspired community. All right, here's Mariam. Mariam, I read on your sort of backstory that you linked to from your website that there was a time where you didn't know what psychology was. And this rang true to me because there was a time I didn't know what neuroscience was. And it's hard to remember that time period. Do you know what psychology is now?
I think I do. I'm pretty sure, although obviously there's a lot of blurry lines between other fields like neuroscience and cognitive science. But I'm pretty confident that now that I teach psychology, I know a little bit more about what it is.
Good. Well, reading your work, one of the reasons why I was interested in having you on is because recently I've had multiple people on talking about the interaction of cognitive functions and how they affect each other, and how the brain is a highly integrative, complex system, and how that kind of changes the views on how we think about cognition and brain function and psychological constructs and stuff. And I'm just curious because we're going to get into talking about much of the work that you have done, but do you feel like you are closer to knowing what you sort of originally wanted to know about how the mind works and how the brains work? Because in my career, I felt the more I knew, and this is a common feeling, the more I knew, the more I realized how much I don't know. But do you feel like you've taken steps closer to knowing what you want to know?
I think, like you, the more I know, the more I realize I don't know and may never know. But I've become comfortable with the amount that we have yet to figure out, and that we may not figure out, at least in my lifetime. So at least at the level of going from neurons to awareness or subjective reliving of our memories. I don't know if we'll get there in my lifetime, but we do have a better appreciation, or I've come to appreciate that we have a better understanding of links between neural networks and components of the mind, and the blurriness between different modules of the brain that used to be considered perception or memory. For example, a lot of my work touches on how a given brain region might support multiple aspects of cognition. So in that sense, I think at a high level, I've come to understand a lot more what brain regions and brain networks might be doing. But in terms of the specific question of, how do neurons and glia and cells give rise to the mind, I don't know if we'll get there in my lifetime, at least.
Wow, you threw glia out there. Glia are becoming more and more important. Huh?
Yeah. I'm not in that particular area of work, but I'm very curious about it. So I've seen and keep an eye out on studies showing that glia might be a lot more important than traditional neuroscience textbooks would have you believe.
Has the target of your interest changed over time as well? Like with, as you do experiments and learn more about what you know and what you don't know, have your questions that interest you, how have they changed over time?
It's interesting because when I first thought I became aware of psychology without knowing the word for it, I was a child and I was looking at these eyewitness science books that had visual illusions in them. And I was absolutely captivated by the Ames room, which I can describe to you if you're interested. But I was just amazed that not only was there this very powerful illusion, but that even if I knew how it worked, I couldn't convince myself to see it any other way. So in that sense, some of my interest started with perception. And then when I went to college, I started to become more and more interested in memory. And so I went into my PhD convinced that I would study memory, only to find myself going back to perception, and then finally kind of merging my memory and perception interests. So in that sense, my interests have both changed and remained the same. I don't always do what I intend to do in a particular part of my career, but I find that my interests have become, fairly broad, but yet somewhat consistent in terms of the way that the different parts of cognition are tied together.
Well, when did attention come into the fore?
Yeah, so that's a great question. So I had went to my PhD to try to study memory, accidentally found myself in perception, and I could tell you a little bit about how that happened. And my PhD research ended up focusing on how the brain's so-called memory systems can play a critical role in our perceptual experience. And so after finishing that work, a natural next step for me was to understand the links between the brain's memory systems and attention, both because attention affects what we perceive and attention affects what we remember. And it was a relatively underexplored part of the field at that time. And so I went to my postdoc to try to find how attention can shape the brain's memory networks and how that can affect what we encode.
Well, that's a lot of what we're going to talk about, but can I back up and ask you, what is the Ames room and why is that interesting? I don't think I've heard of the Ames room.
So the Ames room is this illusion where you, as a perceiver, are looking at what seems to be a regular shaped rectangular room, except at one end there is a person who appears to be giant, and at the other end is a person who appears to be miniature. And so naturally your brain wonders, how can one person, be 5-6 times the size of another? And it's because the room is actually not rectangular. It's set up to be a trapezoid, so that one person is physically a lot closer to you than the other person, and the person who's closer to you appears to be larger. But because of the way you're seeing the room, your brain is convinced that it's rectangular and not a trapezoid, and it's extremely difficult for you to overcome the illusion, even if you know that it's a trapezoid.
Yeah. Okay. So I have seen that, but I didn't know it was called the Ames room. So thanks for educating me.
Sure.
On that. Okay. So you mentioned that you got interested in memory, and a lot of what you study is how specifically hippocampal, what you call hippocampal memory, is affected by attention and affects attention and perception. And maybe we could just start off by talking about the hippocampus, because you already mentioned earlier that you have come to appreciate more how different brain areas can be involved in multiple cognitive functions. And of course, I don't know about you, but and I don't know how it is these days, but when the word hippocampus comes up in textbooks, or it used to, you learn about HM, and hippocampus is all about memory. And it was that way for a long time. And more recently, of course, with the discovery of place cells and all the navigational type signals that are found in hippocampus, now it's all cognitive maps. Now the hippocampus is all cognitive maps, and with the Jennifer Aniston cells, it's all abstract conceptual features in the hippocampus. So, how have your own views on the hippocampus changed over time? With your own research, but also just the way that research has historically progressed, and people have made different claims about the role of the hippocampus.
Sure. Yeah. So traditionally, like you said, the hippocampus is a memory system, and for good reason. When patients have damage to the hippocampus, one of the most notable symptoms and one of the most notable complaints by them is the fact that they now have problems with their memory. So both encoding and retrieving memories. So I don't want to, minimize that the hippocampus does play a really crucial role in memory, particularly because memory loss is the most salient feature of hippocampal damage. And that's why HM was so notable is, you just have this complete lack of an ability to encode new memories after the hippocampus is gone. And so rightfully, people spend many decades in the field to try to understand how it encodes and retrieves memories. But I think, that's a standard textbook view. It's still in the textbooks today. You open a textbook published in 2022 or 2023, and that's the story that you'll find. But I think in the last, 20 years or so, there's been increasing appreciation of the role of the hippocampus in non-memory domains. Some of those are because memory is useful in many settings. So, of course, many of us will study memory because we think it's inherently very interesting and a part of who we are. But memory is also used in lots of settings in which you might not think you're using memory. So you use memory when you're making decisions or trying to anticipate what someone might say next, or when you're trying to solve a problem, or when you're trying to anticipate where you should direct your attention when you're driving. So because memory is so ubiquitous in how it contributes to our behavior, then the hippocampus will play a role in lots of those settings as well. But I think what's more interesting to me is situations in which memory is not needed and not obviously used, but the hippocampus still seems to play a role. And one of those that really got my attention in my PhD was perception. So there was a number of studies done in the late 90s and early 2000s in both non-human primates and in humans, showing that hippocampal damage can impair perception of scenes when they're all on the screen in front of you. So there's no demand to encode anything into long-term memory. There's no demand to retrieve. Everything is there in front of you. And yet hippocampal lesion patients seem to have great difficulties in perceiving spatial relations. And so one of my main interests now is to trying to understand what are the core features of the hippocampus that allow it to contribute critically to memory, but also to make important contributions to these other domains.
Since you said spatial relations, one of the things you often write about is the relational aspects of, let's say, information processing in the hippocampus. What does that mean, and why do you think that that's one of the core functions, let's say, of the hippocampus is relational processing?
Yeah, I've come to think that one of the very important aspects of the hippocampus is its ability to represent and integrate relationships between different features in the environment. So to give an example, within the spatial realm, you might have a room, like your living room, and your living room contains multiple pieces of furniture. You have a couch, you have tables, you have a television, and we know that different parts of the visual stream might be specialized for processing some of those components. So there might be some parts of the visual system that are specialized for processing objects, for example. Based on work from memory and perception, we think the hippocampus is particularly critical for processing the relationships between those features. So not just knowing that there's a couch and a table, but knowing that the table is to the left of the couch. And that if those relations were swapped, then the room has become different in some important way. Or that your living room and my living room could have the same exact components, but if they're arranged differently, that means they are signaling a different room or a different environment.
And so I can relate that very easily to, like navigation, right? Because navigation is all about knowing where something is in relation to where another thing is. How do I relate that to episodic memory as, or is it, necessarily relational episodic memory that the hippocampus is dealing with, and, concepts, right? Abstractions. There must be kind of an easy step from relations to abstractions, since relations necessarily deal with kind of conjunctive features of things.
Yeah, I think remembering relations is necessarily a critical part of episodic memory, because it's not enough to remember that you had a particular conversation. You have to remember who you had the conversation with. Or was it you that said this particular sentence, or your friend? Did the conversation happen yesterday or last month? Was it in your office or in their office? So you're remembering not just details, but also the relationship between those details. And if those details were arranged in a different way, then it's a different memory. So I might have a conversation with a graduate student in my lab Tuesday morning, and I have to separate that from a similar conversation I have with them Friday afternoon. So I have to remember those relations for it to be an episodic memory. And it's not that the hippocampus is the only region that stores relations. So like you said, relations are a key aspect of knowing what concepts are, or having schema for typical structures that exist regularly in the world. So knowing what typically happens when you go to a restaurant is a relational structure or a schema. And there are other parts of the brain that can store that type of relational information.
But when I think of like a concept or an abstraction, I think of somehow losing the relation, and have the abstraction is a higher order concept, right, of something that was built out of relations. So how do I marry those two ideas?
Sure, yeah. So you can think of concepts being acquired when you have multiple experiences with a particular entity, and over time you can abstract the core features of that thing and lose the incidental features that are not important for defining what that concept is. It doesn't mean that you can't still have some of those details somewhere. So in the case, for example, of the Jennifer Aniston cell, it could be that the hippocampus is representing the unique concept of Jennifer Aniston. But of course, every time you see Jennifer Aniston, you might be bringing to mind memories of movies that you've seen her in, or TV shows that you've seen her in.
Oh, I thought you were going to give me a specific Jennifer Aniston memory there.
Oh, I don't have many specific Jennifer Aniston memories, actually.
I don't either, but I'm sure some cell in my hippocampus fires when I see her on screen or something.
Probably.
So earlier you said, in your work on the effect of memory and perception and their interactions, that even when memory is not demanded, right, damage to the hippocampus affects how we perceive the world. When you're doing something that doesn't require memory, maybe the hippocampus just shuts off, right? No, that never happens, right? Your brain's constantly active, sometimes more, sometimes less, and sometimes in different patterns, as we'll discuss. But, how much of, when you think of memory, you often think, except for implicit memory, you think of explicit memory, conscious memory, right? And how much, my memory of cats is affecting something that I'm doing with cats or something like that. But everything's always going on under the hood as well. And do you have a sense of how much that sort of subjective that memory activity might be interacting with ongoing task-related activity that we're trying to bring into, that we're focusing on, that we're subjectively aware of? Like, how much of that is going on under the hood at all times?
Sure, it's a great question. It's also one that I struggle to know how to precisely answer, because by its nature, we're not aware of it. So it's very hard for us to estimate how much is happening. But of course, in laboratory settings, you can try to see cases where people have implicit memories that affect their behavior even without their awareness. And my guess is it's probably a great deal. Like you said, although we're very aware of our explicit memories and memories we know we have and can talk about, there's a lot of ways that our behavior is guided by habits and learned statistical associations and repetitions that we have from doing the same thing over and over. In the case of many of our routines where, we take the same route to work, we walk the same way to our office every day. So some of that is, non-hippocampal implicit memories that might be mediated by other brain systems. But I think there's also a lot of work in the last couple of decades showing that some of those implicit memories might also be hippocampal. So for example, our eyes are drawn to regions of space that might have changed even if we don't have explicit memory for them. So if you think about walking into your office, something is slightly different, you don't know what it is, your eyes might go to that location even if you don't explicitly notice that, maybe a facilities person has come in and cleaned the office and moved some of your things around, for example. So I think a lot of our day-to-day experiences might involve some measures of implicit memory, the way that our eyes move, the fact that we're faster at responding to things that we have many associations or many experiences with. They're not salient to us, but if you think about it, how fluidly you navigate around your house, for example, you're not thinking about it, but you clearly know where to go, the places to avoid so that you don't run into furniture and so on.
This is a total aside, but you conjure thoughts of my wife, who doesn't notice like large changes in the environment. Doesn't seem to notice. And there's a story from one of her old roommates and friends where she would even like test my wife by putting like this big trash bag, like filled trash bag that needs to go out, sort of in the walkway. And my wife would just kind of step over it and go on about her day,
wow.
seemingly not noticing that. What does that mean?
Are you sure she's not pranking you in some way?
She could be, or she could have severe hippocampal damage. I'm not sure.
Yeah, I don't know. With such large salient objects, I think the literature would suggest that even with hippocampal damage, you should be able to notice those.
I think this is a motivational issue with taking out the trash, perhaps. I haven't tested that one.
It could be. Yeah, it could be.
All right, let's talk about some of the findings that you are continuing to generate from your lab, and I'm kind of particularly interested on the interaction between attention and memory, and then there are some other things that I want to ask you about as well. But so traditionally, as you write in your papers, attentional effects have not been found in the hippocampus, or has been scant evidence for them for attentional effects in the hippocampus. Why is that?
Sure. So we started looking at this question maybe around 2013 or so. So that's when I started my postdoc, and I was really interested in how the way that we pay attention influences what our memory systems are representing and what we encode. And of course, there's extensive appreciation of the fact that attention influences memory. And there's also lots of findings showing that attention modulates hippocampal signals of memory encoding and retrieval. What hadn't been found at that point is how attention affects hippocampal representations when there isn't really a demand to be encoding or retrieving from memory. So as you are going around in the world, you pay attention to some things and not others. And we're interested in, even when you're not trying to encode or retrieve any memory, how does your attentional state affect hippocampal representations? And when I started this line of work, it seemed like paying attention to the left or right side of the screen or paying attention to faces versus houses didn't really seem to affect hippocampal activity at all. And that's in stark contrast to how attention affects visual systems, where if you're paying attention to a face versus a house, there is extremely robust modulation of signals in visual areas. And we figured that some of those null effects in the hippocampus might be because the hippocampus doesn't really care about individual objects as much as it cares about relationships between objects. Mm-hmm. So that was one reason. The other reason we thought that there might have been null effects in those studies is because the way that attention affects visual systems might be different from the way that it affects the hippocampus in terms of the actual signature you're looking for. So the most robust way to look for attention effects in the brain is to look at, are areas more active when you're paying attention to the features they prefer compared to when you're not paying attention to those features.
And that's because attention is traditionally, well, one way to think of attention is sort of gain modulation of salient things, right? Increase the activity of your brain to salient features and decrease them to non-salient features, for example.
Exactly. So this gain modulation is one of the signatures of attention that has received a lot of investigation and is a really robust signature to find in the brain. So of course it's reasonable then to look for the same gain modulation in the hippocampus. But we'd also noticed that there was some exciting work from rodent models that was coming out around that time showing that attention affects not how active different cells are in the hippocampus, but how stable they are in their firing. So place cells, which fire when an animal is in a particular location in the environment, tend to be more stable in their firing, more precise in where they fire when the animal is paying attention to the spatial environment versus other aspects of the environment. So we thought that maybe prior studies had missed signatures of attention in the hippocampus because, one, the studies they were using were maybe not optimally designed to tax hippocampal relational processing. And second, you might have to look not just at how active the hippocampus is, but also how stable its representations are.
So, okay, make the connection for me between stability and, okay, so let me back up. The old way of doing fMRI, which is currently still in use, is to look at some area and say, is that area, does it have signatures of higher oxygenation levels there, higher bold signal? And that must mean it's more active and you're using that area more. And that's still traditionally, like you said, when you look in visual cortex, for instance, when you're performing something and you're paying attention to the left side of the screen, your right visual cortex will have a higher bold signal, right? And then the inference there is that your right visual cortex is more active, is working harder. I'll back off on working harder because that's something I want to ask you about.
Sure.
But then, multi-voxel pattern analysis came along and started looking at different patterns of activity among all of the voxels. But and then you can compare like the patterns of this wide array of voxels of areas in the brain, and then differentiate cognitive functions based on those patterns. But how does stability relate to those two aspects?
Sure, yeah. So stability is related to the second aspect that you talked about of looking at multivoxel patterns. And so the idea behind stability is just how similar are those patterns across different instances. So imagine you're doing a task where you're viewing pictures of rooms, and half of the time I tell you to pay attention to one feature. So I tell you to pay attention to the relative positions of the couch and the table, and the other half of the time I tell you, pay attention to the windows. The idea with stability is that when your attentional state is the same, the activity patterns in the brain or in the hippocampus might be more similar. So we call them stable because the idea there is that every time you're in a particular state, the brain reinstates a particular activity pattern that is similar or stable across those different instances.
Well, I thought you were going to describe the art gallery task that you employ.
Yeah, I was subtly hinting.
You should.
That.
Let's explicitly describe it, I suppose, because it's not a far cry from what you just described.
Sure, yeah. So one way that we've been looking at attention effects in the hippocampus is by having people do a task that we've been calling the art gallery task. And the idea there is that you can present people with a relatively naturalistic stimulus. So in our case, it's images of 3D rendered rooms. And we get them to pay attention to different features. So half the time we tell them to pay attention to the spatial configuration of furniture. So we create these rooms that have really unique layouts, unique angles in the walls, unique spacing and sizing of the furniture. And half the time we tell people, pay attention to the spatial configuration of the room. So where are the walls? What are the angles? How is the furniture arranged?
This is the relational part.
Exactly, and particularly spatial relationships.
Right.
Then the other aspect of the task is that we hang the painting in each room. So we place it on one of the walls, and the idea there is that maybe you're walking through an art gallery, and you sometimes are paying attention to the paintings, and sometimes you're paying attention to other features. So half the time you're paying attention to the spatial configuration, and half the time you're paying attention to the art. And people have to do different tasks. So in the room task, they're looking for rooms that have the same spatial configuration, even if your perspective is shifted. So if you are looking at a room, you have to be able to recognize that this is the same room, same furniture, same arrangements, but your perspective has shifted by 30 degrees or so. In the other half of the trials, we call those art trials. We tell people to look at the paintings and try to identify paintings that were painted by the same artist. So you're trying to identify paintings that are similar in terms of the choice of color, the content, the brushstrokes, and so on. So that was a way that we could try to manipulate different types of relational attention and see the effects on the hippocampus.
And those effects were not, the signature of those effects were not borne out in the overall bold activity, right? But what you were just referring to is the stability of the patterns. Could you just describe that a little bit more?
Sure. So interestingly, we actually saw opposite effects on the bold activity and the stability measures. So in the hippocampus, we surprisingly observed robust deactivation when people paid attention to the room versus the art. So this was unexpected for two reasons. One is that prior studies didn't show any modulation of overall bold signals, so we were surprised to see an effect there. But the second reason it was surprising is the robust deactivation for the room versus the art task, because there's so much literature suggesting the hippocampus should care more about spatial features. But surprisingly, we saw the flip of that in the stability measure, where hippocampal activity patterns were much more stable across different room attention trials than different art attention trials. And this stability measure also predicted how well people did on the task. So this suggested two things to us. So first, the signatures of attention in the hippocampus might be different from those in neocortical areas. And second, that deactivation doesn't necessarily mean disengagement. So you could have deactivation in the hippocampus for spatial attention, but more robust and more stable patterns that predict people's behavior.
I just want to add, okay, so this is another aside, but fMRI has always given me pause because, so I grew up in science recording single cell activity in non-human primates, right? So action potentials. So of course I'm biased to action potential signals, right? But I understand the value of fMRI, but the interpretation has always been somewhat up in the air. I mean, there have been, plenty of studies looking at how bold signal relates to local field potentials and spiking activity. But okay, one thing is you mentioned that maybe attention is modulating the hippocampus differently than it does more sensory related neocortical areas. So one question would be, why would that be? and sort of another question would be like, are we just missing stability information because we're not measuring it in like early visual cortex, for example? Maybe before I ask.
Sure, yeah, those are great questions.
Go ahead, yeah.
Yeah. So I will say we did also observe stability in visual areas. So they also showed modulation of how stable their activity patterns were across the two tasks. Some showed more stability for the room versus art. Some showed the other way around. However, in cortical areas, those stability measures will highly relate it to the fact that those areas showed more bold activity for one task than the other.
Everything went up, and therefore you could say it's more stable. Is that the...
Exactly, yeah. So parahippocampal cortex loves scenes. It's more active for room attention than art attention. Its patterns are more stable for room than art attention. But that stability was because voxels that are more active were more stable across different room trials. So that suggested to us that maybe the neocortical signal is a little bit different than the hippocampal signal, where activity and stability were dissociated and unrelated at the voxel level. But I do want to acknowledge that the bold signal looks different in hippocampus and in neocortical areas. And the coupling between aspects of the bold signals and local field potentials is also different across the hippocampus and neocortex.
Oh, I didn't know that. What is that relation?
So some studies have found that there seems to be sometimes a lack of relationship between bold signal and hippocampus and different aspects of the local field potential. Whereas in neocortical areas is usually a relationship, a positive relationship. So, for example, gamma could be related to higher bold signal. That's not to say that the bold signal is not meaningful in hippocampus, just that it might not be as closely tied to some aspects of neural firing. So if I was going to amend what I said earlier, it's not necessarily that attention acts differently on hippocampus than neocortical areas, but the way that we're measuring it with fMRI looks different in the hippocampus versus neocortical areas.
So I've always had this naive thought that, so years ago, there was a correlation made between the LFP signal and bold signal and oxygen levels. And the interpretation of that is that bold is more of a measure of incoming signals, right? The signals coming into the dendrites, and less a measure of outgoing signals. It's less correlated with spiking activity. And one interpretation of that is that, a brain area is working harder when there's higher bold, right? Is another, and I'm sorry if I don't know this from the literature, but another interpretation of that is that it's less efficient. It's working less efficiently because it's having to, you can imagine a circuit, right, in some very automated behavior that just fires really quickly and gives rise to very little bold. And maybe that's related to the lower activation and the stability patterns that you saw. And so one interpretation of bold anywhere in the brain is that a higher bold means less efficient processing, and which is kind of the opposite of a higher bold signal means that area is involved in the task more than some other area, right?
Yeah, I agree with that completely. And I think based on my work, I'm very hesitant to conclude that lower versus higher relative bold signal necessarily means anything in particular. The fact that there's differentiation in the bold signal across tasks means that there is a signal related to the task. But in terms of whether more is better or less is better, I'm not going to reach conclusions, at least based on the work that I've done and that I've seen. So we interpreted the hippocampal effect exactly the way that you mentioned. So lower activity, more stability might mean more efficient processing or kind of silencing of irrelevant information. So you have low activity, maybe only the neurons that are, of course, I'm jumping to neurons, which is a big leap based on fMRI, but could mean that only the neurons that are the most relevant are firing, and there is suppression of the ones that are irrelevant or not needed, which could lead to lower activity, but more stability. Here is where I think it's really important that we not just focus on fMRI, but the convergence of results from fMRI and other methods. So, for example, if fMRI told you that the hippocampus seemed to be disengaged by a particular task, but then hippocampal lesion patients cannot perform well on that task, then we should amend our interpretation of fMRI. It doesn't mean that less activity is disengagement. It means that there might be more efficient processing or something else that's going on.
Maybe we should talk about how, you've studied, first of all, you've caused me to start smoking again with some of your research.
Oh, no.
No, I'm just kidding. I just inject nicotine or acetylcholine
That's
into
funny.
But your results could potentially cause someone to rethink whether they should quit smoking, because you've looked at effects both for damaged hippocampal in patients with lesions to the hippocampus and how attention affects memory in that way. And you did a smokers study. So how what have you found with smokers and with damaged hippocampi?
Sure. I'll start with the hippocampal lesion patients, but without first just mentioning a caveat that, every time I talk about this work, I try to encourage people to not smoke because of the results of the study, that the effects that we see on behavior, while positive, are not going to outweigh the devastating effects on one's health if they
unless
smoke.
all you care about is having a better attentional effect.
Indeed, that's true. And of course, I'm appreciative that we have been able to use samples of cigarette smokers to get some of the insights I'll share with you. But of course, it would be better if people didn't smoke in general, despite the benefits it gives to me personally for my research.
Have you had media outlets reach out to you? Because this is sort of something that would make for a good headline, right? Smoking.
I'm trying to wonder. I'm just trying to remember if they have. I don't think anybody has reached out about that particular study. We'll see what happens after this podcast.
Oh, sure.
Of course.
Yeah. Okay.
But yeah, so to backtrack a little bit, so we had designed this art gallery task that we initially had used in fMRI, and the story there is that hippocampus was modulated by the task and seemed to be particularly important when people were paying attention to spatial relationships. So the next two questions we wanted to ask is this hippocampal modulation actually critical? So is it doing something necessary for the performance of that task? And if so, how is that happening, or why is it happening? So we recruited a sample of patients with medial temporal lobe damage. So of course, the first caveat here is their damage was not restricted to the hippocampus.
Yeah.
Some of them had more extensive lesions. And even for the patient whose damage seemed to be restricted to the hippocampus, of course, there's going to be broader network abnormalities. But the main lesions in these patients were in the hippocampus and surrounding cortex. And we had them do a version of the art gallery task where they're trying to find rooms with the same spatial layout or trying to find paintings by the same artist. And we find that these patients are totally fine when they're trying to find paintings by the same artist, and they are very impaired when they're trying to find rooms with the same spatial layout. So statistically, the patient group was not different from chance levels. And I'll say here that, we showed them 2 images on each trial. The images were on for a couple of seconds with, a couple hundred milliseconds between them. So everything should be within the realm of, online perception, potentially working memory. There weren't any demands to encode anything into long-term memory. So from that study, it seemed that the medial temporal lobe generally is probably doing something critical for the performance of the task, because these patients could do other attention tasks, but were at chance at finding rooms with the same spatial configuration. So that's why I kind of linked earlier to converging results between fMRI and patient studies. So hippocampus showed deactivation for the room task, but it seems to be playing a really critical role in performance of that task.
Can I just interject, because we were talking about, the classic roles of hippocampus and abstraction being one of them, and we talked about how abstraction and concepts are related to relational processing. And it seems like judging whether the same painting was hung on the wall in different presentations of the stimulus is somewhat related to abstraction and concept formation. And maybe not. Maybe it's just related to statistical features of the art or something like that. But in that sense, your results, do they argue against a role for abstraction in the hippocampus? Does that make sense?
Yeah, it does make sense. I guess that hasn't been the way that I've been framing the task, but I think it is an appropriate way to think about it. So when you're trying to find rooms with the same spatial configuration, you might consider that as a demand to abstract away from the specific features you're looking at with any given snapshot of the room, and to find the same high-level relationship in another view of the room. So something I didn't mention earlier actually is that the rooms with the same spatial layout were different in other ways. So we changed the wall colors, we swapped chairs with different chairs. So you couldn't do the task just by looking for identical features that repeated. You had to form a higher level abstracted representation of the spatial layout that wasn't so dependent on the specific visual features you saw. And
Right.
same for the art.
But
the paintings were not identical, but had abstract similarities.
Right, but the effect that you found was specifically for the spatial layouts, right? So it does seem to be much more spatially, I guess, spatial memory abstraction. I guess you can there's room for all three of those interpretations.
Sure. Yeah, I guess what I wish in hindsight I would have done differently is had a task that was as relational as the room task, but in a non-spatial domain. So when we got the results we got, which we were actually a little surprised because we thought the art task would be quite relational as well. We realized that there are probably ways to do the art task based on paying attention to individual features or summaries of features like color. And although that wouldn't be a perfect strategy, it might get you decently good performance. So one interpretation of our results is the hippocampus really cares about space. The other interpretation is maybe the spatial task was more relational and the art task was less relational. And if we'd had a better task that had as much relational demands as the room task, but not spatial, the hippocampus might have been just as involved. The challenge there is to quantify.
Right.
Relational.
That's what I was going to ask you. Have you had thoughts on how to do that?
I don't know the best way of doing that. Space is a really convenient way of studying relationships because you know what the relationships are and you can manipulate them very precisely. Chair to the left or right of table. Time is another feature where you could manipulate relationships. So relative temporal onsets, for example. With art, maybe we, went a little too high level and it was a little difficult to define what the relations were in the first place and how many of them there were, obviously.
Do you know the study of the relational birds that have been used, like where the birds
Tim Behrens?
Yeah, by Tim Behrens. I'm wondering if you could just use those stimuli and somehow. I'm not sure if he quantified I guess you can quantify how much the legs are stretched and the necks and stuff like that. So that might be something, but then that's also kind of spatial.
Yeah, that's an interesting idea. I guess it's also kind of an object insofar as it's a self-contained, a duck is more object-like than it is a scene, which could be okay, but there is work suggesting that the hippocampus might care less about relationships within objects than relationships across scenes. But it would be a good control task where you could at least manipulate different relations in a different type of stimulus.
All right. Anyway, I'll get my people on it and we'll figure this out. How to...
Perfect. Let me know when you do.
Okay. Yeah. Okay. So, but I interrupted you and I don't remember where we were. If
Oh, yes. The cigarette smoking study.
Sure.
So based on our fMRI and patient data, we thought that we had some evidence that the hippocampus is important in attending to spatial relationships during these rapid online attention tasks. And we wanted to understand the mechanisms by which that happened. So what are the neuromodulatory systems that might allow the hippocampus to contribute to performance in perception tasks? And we were very motivated by computational modeling studies and work with rodent models showing that the hippocampus might switch between states that are optimized for attending to the external world and states that are optimized for retrieving memories. So these kind of switches between internal and external modes. And that work suggested that the acetylcholine neurotransmitter system might be important for biasing the hippocampus toward this outward state, where it's paying attention to the outside world rather than to internal memories. So we thought, if that's true, then if you manipulate the cholinergic system, you might be able to get people to perform better on attention and perception tasks that are recruiting the hippocampus. So what I really wanted to do is, a double-blind pharmacological manipulation with a cholinergic agonist versus a placebo, and see whether we could get better performance on hippocampal tasks with cholinergic agonists.
But you couldn't?
The problem was,
Yeah.
Well, so I was in my first or second year and as assistant professor. So I just starting my lab, and the advice I got was, maybe don't do this before tenure. It could take 5 years. It was very logistically challenging to do that.
Yeah, and yeah, a long time. Yeah. But okay, but then the other route is just to recruit smokers, I suppose.
Yeah, exactly. So my first thought was, okay, maybe I'll put this project on hold and revisit it after tenure when I can, have the flexibility and the time to do a study that could take many years and be logistically very challenging. But then I was, talking to other people in the department, and one student said, "Why don't you just test cigarette smokers?" And I thought, if it's between not doing this project or maybe waiting 5 to 8 years and doing it versus just, having a fun study on the side, why not just do it and see what happens?
How messed up, though, is our current system, right? Our current system that really affects your research, thinking about your career and what is good for your career versus what is best for science. And we don't need to perseverate on this issue, but it's just a shame.
I think it is. And, some people will say, I'm just going to do the research I want to do, regardless of whether it's ideal for me right now. I was a little too scared to do that.
Rightly so.
And I figured, and I think it would be better if we prioritize slow, careful science, rather than counting publications or looking at where those papers were published. I think there should be a lot of credit given to people who do studies carefully and slowly and well-powered and reach conclusions that are robust and replicable.
But for now,
I don't think we're there.
At least in the United States, right? I think that there are systems in Europe where you're automatically you sign up in your tenure tract unless you screw it up or something like that, right? Anyway, this is a political conversation now, but at this point, maybe people should go to Europe if they want to do slow, careful science.
Yeah, I do hope there could be a cultural shift towards slow and team science too. That there's no need for, individual labs to kind of try to do everything alone and potentially reproduce the same scientific question and same experiments across labs rather than collaborating. It might be a better use of money as well. So I do hope that maybe we'll move towards that in the future.
You know what? One good use of money is purchasing cigarettes because they're very expensive. So.
Yes, indeed. Yeah. So that'll take me back to the study where we, decided just initially it was like a fun side project. Why not just try it, see what happens, and if successful, that could open the door to a lot more people being able to do pharmacological manipulations, people who don't have access to the resources or the medical schools that are needed to do other types of drug studies. So we recruited people who smoke cigarettes, and we asked them to participate in 2 sessions. One was one in which they woke up, they smoked the usual amount they smoke, and then they come into our lab.
But these were light smokers. I'm sorry to interrupt. They were very light smokers, right? Yeah.
Yes, and that's a critical point to make, so thank you for bringing that up. We selected people who are relatively light cigarette smokers who did not count as dependent based on a questionnaire that we gave them. And the reason for that was to avoid the withdrawal effects that you would get with people who are heavier cigarette smokers. So these were people who smoked maybe a few cigarettes a week. So they would come in, they smoked, 1 or so cigarette. They came into our lab. They did the same study that we used with the hippocampal lesion patients. And we compared that to a session in which we told them to not smoke for 12 hours before coming into the lab. both sessions were first thing in the morning, so it's not that we were asking them to, go an entire day without smoking. They went to sleep, they woke up, maybe had a few hours, and then came to the lab. So then we had an on-nicotine session and an off-nicotine session. We were not very confident that people would follow our instructions. So we purchased a carbon monoxide monitor for people to breathe into. So carbon monoxide turns out to be a very effective way of measuring how recently someone has smoked a tobacco cigarette. So if you smoke, carbon monoxide levels go up and they decline slowly over hours. And this measure is also very highly correlated with nicotine levels in the person's blood. So we could use this carbon monoxide measure to make sure that people, followed our instructions. And second, to have a measure of nicotine.
Because what you're saying is all smokers are liars. I get the, see the
no.
causal connection here.
I generally have very low faith in people following instructions.
Yeah, sure.
Across the board, and that includes everybody. But yeah, so we had this carbon monoxide level for each individual. And we had their performance when they were on nicotine and their performance when they were off nicotine. And what we found was that individual differences in these carbon monoxide levels, so essentially a measure of how much more someone smoked on versus off nicotine, predicted the performance enhancement on the hippocampally mediated room task. So the people that showed more smoking in the on versus off session tended to show the greatest boost to their performance when they were on nicotine, specifically in the hippocampally mediated task and not some other control tasks that we had. So that was consistent with the idea that higher cholinergic signaling might bias the hippocampus toward this external attention mode that could improve your performance on external attention tasks that tax hippocampal processing.
How important are these attentional effects? Like, how big are they, right? For instance, and I'm jumping ahead here, but one of the things that you've studied is how attention on states when people are at highly attentive states versus when they're not paying attention to something, how that affects memory. And you found effects there, but then compared to what's called the temporal context organizational structure of memory, essentially where when you think back in time, you don't remember things out of order. You remember things in the order in which they happened at the time. And that effect was just dominant, right? And so I'm not sure if this is a fair question to say, I'm not asking you like how much power your results yielded, right, statistically, but just your overall picture of how much attention is affecting our memory.
Sure. Yeah, I think attention can have stronger effects on some types of memories than others. And different levels of attention also matter a great deal. So if you take an extreme example, if you are paying attention to a movie versus completely zoned out looking at your phone, taking a nap, you're not going to remember the movie in that latter case. So whether you're paying attention to something or not, whether your attention is full or divided, those will have robust effects on your memory. Other types of attention might matter a little bit less. So say that you are, generally on task and paying attention, but every once in a while, you're paying a little bit more attention than others. In that case, your memory might still be decent in those periods where you're out of the zone, not paying attention as much because you're still generally on task. So I think, some types of attention matter more than others for memory. And if you're generally attentive, more might get in than you would expect.
I was trying to, in preparation for this conversation, there's a phenomenon that I've experienced personally, and I assume other people experience it also. So I'll ask you about it. I have found that, so obviously when you are paying attention to what you're doing, you're more likely to remember it better. But then there are certain things in my personal experiences, and I cannot conjure one right now, where I just can't seem to remember something, and there are experiences where I think to myself, pay attention now, right? Like studying for a test or something. This is what I need to remember. Focus, pay attention, so it's sort of a self-talk and a desire to pay attention. And there are certain types of memory, I suppose, for which that does not work for me, for which I fail over and over. Even though I am trying my hardest to pay attention, I'm kind of confident that I won't remember it later, and then I don't. So what's wrong with me?
Oh, I don't think there's anything wrong with you in particular. That's the good news. So I think all of us probably have that experience. I think part of it is because attention matters, but it also matters how you engage with the material. So, for example, I'll give an example for when I was in college and trying to study for exams. And I'd read the textbook and I'd tell myself, you got to remember these details, and I would try to highlight the ones that I thought were more relevant. But it felt like in the act of highlighting and trying that I was doing the work, but I wasn't. Yeah. It was offloading. Yeah. It was highlighting is not the same as committing to memory. And I wouldn't remember anything I read. So I think it wasn't the intention that was enough. It's how I engaged with the material. And I felt like trying to form rich connections or associations and testing myself was a lot more effective. So not just this detail is important, try to remember it, but how can I remember this? How can I link this to other things that I know? What are the features of it that I think will help me access it later? And then trying to test myself on it, 5, 10, 15 minutes later, a day later, to make sure that I retained it.
So you fixed yourself, and I'm just a poor learner, I suppose, is the
No, I still have that experience, particularly for real life events or
where you're not consciously thinking I need to engage in it in a certain way and do some interval training and do some then I have terrible memory for a lot of things, including movies and books. Even if I'm engaging with them and I would like to remember them, they're there in my mind for a while and they're gone later. And I think part of it is because I'm at least a lot more distractible than I think I am. So I've caught myself a lot mind wandering when I'm reading or watching television or whatever. And I think it's not that I'm trying to remember at some places, but I'm often switching to my internal mode and thinking about things that I need to get done, and that's just distracting. You need to start that smoking, right? Smoke when you read.
That's right. Maybe.
All right. Well, so we've talked a lot about how attention affects memory, but you also go the other way and you study how memory can affect our attention. And in this particular case that I'm thinking of, you're looking at hippocampus and medial prefrontal cortex. Maybe you can just say a word about what you found about how memory itself, in turn, affects attention as well.
Sure. Yeah. So a lot of the ways people study attention, and a lot of ways I've studied attention in the past, is telling people what to pay attention to. And of course, that's common in many aspects of life. You're teaching and you're telling people, hey, pay attention to this lecture I'm giving. Attention is also sometimes captured automatically. If you hear a loud noise or, something jumps in front of you, your attention is going to be captured by that. But there's also been a lot of interest in how our memories of past experiences guide what we pay attention to in a particular setting. And we've been really interested in how our long-term memories can affect what we pay attention to or serve as guides for our attention. So we were interested in seeing hippocampal contributions to memory-guided attention, with the idea that if your memory tells you what to pay attention to, you can prepare better. So if you know that you're going to walk into a room and the projector is in a particular setup and you know where the lecture is going to be, you can have anticipatory attention to the correct place in the room. And we were inspired by a lot of the work in memory research showing hippocampus anticipation signals. And we were interested in whether the hippocampus can anticipate what you're about to pay attention to. And so we had people do tasks where they could, based on memory, know what they're supposed to pay attention to in an upcoming trial. This was, again, the art gallery task. So you could know in the next few seconds, I have to pay attention to spatial configuration or to artistic style. And the general finding was that hippocampus showed a preparation signal. So its activity patterns when you're about to do a room task are the same as the activity patterns when you're going to do the room task. So it's as if it has this preparatory configuration so that you can do the task, with a head start when you start the trial.
How does it get that preparatory configuration? Because one way to think about that as well, you have to then attend to the appropriate memory, right? So then it's like attention grabbing the right memory, and then the memory is going to affect the attention?
Sure, yeah. There was a couple of different ways that you could think about the preparation signal. So one is maybe the hippocampus is retrieving similar memories. So it's retrieving memories of other times you've done that task. And the preparation signal is just you thinking of those memories. Another way to think about it is that you know generally what it's like when you have to process spatial information. So maybe your attentional state has to be wider or broader. And so it's a relatively abstract attentional set geared towards specific types of information.
So it's like it gears up, and by gearing up, it puts it into that, maybe we could say low bold or more stable state to prepare because it needs to be online for the task at hand.
Yeah, that's the general idea. At least that's how we interpret the data.
Yeah.
Yep.
But you saw these same kinds of signals in medial prefrontal cortex, right?
That's right. The difference between the hippocampus and the medial prefrontal signal, if I'm remembering correctly, is that the hippocampus showed more preparation when your attention was guided by memory rather than just us telling you that you have to pay attention.
And wasn't it more... there was a bigger effect for the spatial aspect as well, and medial prefrontal cortex didn't care as much about that relational spatial aspect, or maybe I'm not remembering.
Yeah, I don't remember if we found that particular result. I think there we just focused on preparing for either room or art, but didn't separately look at preparation for spatial versus non-spatial.
So then zooming way out, which is unfair to do, to ask you to make a grand sweeping conclusion about attention and memory and the relation between them. What kind of big picture do you have in mind for how attention and memory are related and interact? And then, of course, how that happens in brains.
That's a very big question. So I think
you have 12 seconds to answer. No, I'm just kidding.
Oh, no. I think the general way we're viewing it is that there's no clear dividing line between attentional systems and memory systems, but they have to be fundamentally interactive, and that attention can shape what your memory systems are doing and how they're doing that. And these memory systems can also then affect what you're paying attention to and affect different attentional systems.
But so attention is notoriously slippery, just conceptually and in terms of mechanisms, etc. But memory also is still historically debatable how many different forms we have. There's the encoding, the storage aspect, the retrieval. I mean, there's all these different facets of memory. Where are we in terms of understanding what memory is and how it works, and what attention is and how it works? How do you view that in the large scheme of things?
Mm-hmm. Yeah, I think the challenge there is that there's many types of memory and there's many types of attention, and they can look very different. So it's not always clear that they're really the same cognitive process that we're studying, depending on the specific instantiation of memory or attention that you're looking at. So attention that's automatically captured by sudden movement might look very different in the brain than attention that's guided by your memory. You can prepare to direct your attention to a specific visual feature, a specific location in space, a specific type of task, and those are all going to look very different as well.
Specific memory.
Or a specific memory, yep. And likewise, you might be interested in memory for an episode, so our conversation today. You might be interested in your memory for how to tie your shoes or how to ride a bike, and all of those are going to look very different. So I think the cognitive labels of memory and attention are very useful because they are convenient shorthands that we all intuitively understand and can communicate, and also allow us to communicate our science to the public. But it might not be that your brain respects those particular divisions. There might be so much variation within memory or attention that one word to describe them doesn't adequately capture the way that your brain represents the different features. But they're convenient shorthands for talking about our science.
Well, I mean, I mentioned that the smoking study, right, would make for good fodder for a headline. And then I thought, well, what would that headline be? It's something like smoking improves attention, right? And maybe I'm doing a disservice by even like saying that out loud, but then that masks so many subtleties and details of what attention is, and is it carbon monoxide or is it
Sure.
the subtleties of the study. I don't know, maybe that's just commentary, but I just continue to grapple with these psychological notions that we are continually refining. So I was just kind of curious in your own head how comfortable you are with these sort of shorthand notions. But I guess for someone, an expert like you, that shorthand notion opens up this wide net of detail that then you can explore that more detailed conceptual space as well.
Exactly. Yeah, I like to differentiate between concepts that I think are useful for communication and ones that I think are useful for shaping our research. So I think the difference between perception and memory is important for talking about what we're studying and talking to the public and loved ones about aspects of our experience. People intuitively understand that when you talk about memory, you're talking about the representation of something that might have happened a while ago that is no longer here. And when you're talking about perception, you're talking about something that's in front of you. And I think that's useful. It's a good shorthand for, introducing our tasks to each other, for example. But it's not so useful for thinking about how the brain and cognition are carved, because it's very difficult to separate perception and memory in behavior. You can't have memory for something you never perceived. And the brain, probably, in my opinion, is not divided along the lines of perception and memory. There's no module in the brain where perception ends and memory suddenly begins. So I think these concepts are not going to define the way that I ask particular research questions, but they're still useful for talking about and communicating the research.
You said modular, and I've recently had Luis Pessoa on and Michael Anderson, and we've talked about the breakdown of that traditional modular view of the brain, that everything is in these well-defined modules. And I know that you're interested. I mean, I know that you basically agree with that essentially, right? Because you've written about it multiple times and thinking of the hippocampus as a module and the memory module. And yet, when you look at networks and functional connectivity and look at resting state networks, there are different quote unquote modules of the brain in terms of these larger dynamic networks. How modular is the brain?
Yeah, it's modular and it's not. So it's modular. You can have modularity in terms of particular areas that are more likely to form networks with each other than others, or different brain states that you might switch between. But I don't think those modules map onto discrete cognitive processes, that you don't have one network that only does memory and nothing else, or a network that only does perception and nothing else. And those networks communicate. So even if there are some systems that are more connected or more coupled than others, it doesn't mean that they're not also sharing information and receiving information from the other networks. So in that sense, there is some modularity. There's some systems in the brain that maybe show a bias to communicate with each other, or might be preferentially associated with some types of information processing. But I don't think that information processing then has a one-to-one mapping with a type of cognition. So, for example, I think relational representations are a very important aspect of hippocampal function. But these relational representations can be used for perception and memory and problem solving and language and attention and creativity and lots of other domains.
I was going to ask, what would we do different studying HM these days under that perspective?
Yeah, it's a great question. It's a challenge because, when you're first discovering a particular phenomenon, it's very reasonable to try to understand, what is this brain area doing and what is it not doing, and to study that using the particular tasks that are available to you at that time.
At the time.
And over time, you could try to, find the blurriness between the different boxes or the different tasks that you've used, or maybe find how the tasks are different, not only because of memory versus attention, but also in the representations or the complexity of the stimuli. But I think, the way that HM was studied was a very reasonable way to start.
Yeah.
And then the further the research goes, the more you're able to find the blurriness between the different tasks and concepts.
Yeah, there's a lot of reinterpretation of what the results mean these days, right?
Sure.
With HM, which is at this point all we can do. I guess we need another HM, but let's not hope for that. How modular is the mind, right? So you talked about there not being a one-to-one mapping between a brain area and a cognitive function, but how are cognitive functions, given your research studying the interactions between what we use shorthand, we use shorthand words for memory, attention, but there's just this massive interaction. There seems to be this massive interaction between these cognitive functions. So how modular is cognition?
It can't be very modular, I think. So I always talk about the relationship between memory and perception when I teach, because, vision is something that seems to be very, sensory. You open your eyes and you see things. But memory and learning play a huge role in perception. And so I sometimes tell my students about these studies of people who, have been blind since childhood or birth and regain sight in adulthood. And if vision was just, your eyes getting light and you seeing, then you would expect that an adult who regained sight would open their eyes and they'd see just the same way that you and I do. But that's not what happens. So these people who regain sight in adulthood actually have a lot of trouble making sense of what they see. And that means that seeing requires experience and learning, and that means it requires memory. There's also, when you see an object, you're of course, using the pattern of light that hits your eyes to interpret what that object is, but you're also using your memories and other information. So if the object is partly occluded, you're able to use your memories and experiences to figure out what the full object looks like. So perception requires memory. There can't be memory without perception, because what would you learn and remember unless it was something that you had a sensory experience with? So I think it's very easy to find ways that the mind can't be modular, but has to be interactive.
Given all your research, here's where the fun part is. Do you have practical advice for people who are trying to improve their attention, improve their memory? How to go? Have you altered anything about your daily going about life, etc.?
Sure. I'll do attention first and then I'll do memory.
Okay.
So the attention part is, like I mentioned earlier, I've noticed how distractible I am, and particularly how often when I should be paying attention to stuff around me, I'm instead mind wandering or planning or thinking about something that happened earlier in the day. And if you start to pay attention to how often that happens, for me at least, it happens all the time.
Yeah.
So I'm trying to be better at, trying to live in the moment and appreciate what's there. And by constantly reminding myself to try to focus on, things that I'm looking at or things that I'm hearing. And when I catch myself doing that mind wandering, to try to put myself back into this externally oriented mode.
But you have to remember to do that.
I have to remember to do that. Some people might be better at it than I am. People who engage in meditation practices might be able to better kind of keep themselves attuned to the here and now and the sensory signals around them. I I'm constantly living in my head. So I have to remind myself to, switch and pay attention to, what I'm doing now, and appreciate the sights and sounds around me. For memory, I think intentionally engaging with material in a deep way. So trying to find associations between what you're trying to remember and other things that you know. Making mnemonic aids for yourself, and testing yourself are really key. So trying to generate the information rather than just read it and assume that you remember it. One way to do that is, telling people the things you learned that day. So, if you saw a cool talk, you can try to tell your wife about the cool talk, and that might help you remember it a little bit better.
Yeah. Have you ever... So this mind, like, I'm always in my head as well. So what you're saying is really resonating with me, and I immediately feel sorry for you because I feel sorry for myself, am embarrassed that it's much better these days. But I remember in high school and especially in college, I would read an entire chapter and then realize I was mind wandering the entire time, and my eyes had scanned all the words. I perceptually took it all in and it was just gone. And I always thought that was just me, that I'm particularly poor at focusing or something. But maybe it's a little more widespread than I'm appreciating.
It happens to me all the time. And I think it also coincides with how stressful the other things in my life are, and how boring what I'm reading is. So, if it's a particularly boring thing and I'm very stressed, there's no way I'm going to remember anything that I'm reading.
Yeah. So you said stress, and another thing that you write about or have written about is your kind of trajectory in science and throughout your career and some of your own personal struggles. So if you don't mind, I would love to just kind of talk about that and where you are these days and, how you think about that. So I was surprised when you mentioned that you, like me, are constantly just in your head and mind wandering and maybe struggle with focus and depending on stress levels and stuff. Because I was, having read a little bit about your own personal journey, I just assumed that you were a super focused overachiever. But you can correct me.
Sure. Yeah, that's a fair assumption. I think probably many people would assume that. And certainly in school, that's how I appeared to be. I was a very focused student. I probably took school a little too seriously. I could have maybe relaxed a little bit more, but I was very focused on trying to do well. I remember going into college and being told, you should expect your grades to drop by 15 percentage points.
You're like, screw that.
And
that's not
I found that terrifying, and my first chemistry exam, the class average was something like 56%. And I was terrified. I just was set on trying to do well in school for my future career. And, that led to a lot of anxiety. It led to a lot of mental health problems that took various forms. And it was something that I struggled with throughout undergrad, and that got particularly worse in graduate school. So I did struggle quite a bit with my mental health during those times. Tried to maybe focus a little bit too much on school, which was meant to kind of reduce my anxiety about doing poorly, but just meant to actually, it ended up increasing anxiety and stress because I didn't have other parts of my life to enjoy. I didn't have that social support group, for example, because I had focused so narrowly on work that I had excluded friends and family and were just kind of spiraling into a bad mental space.
Was that an intrinsic property of your personality, or was there, where do you have like external influences that like pressure? And I don't mean to like point fingers of blame, to your parents, but I know a lot of people are, heavily guided and motivated by their parents' expectations and society's expectations?
Sure. I certainly had pressures coming from various sources, but when I started getting really mentally sick, I had a lot of support from my family, who was extremely alarmed to see the trajectory I was going down on. I had a lot of support from my undergraduate advisors and people who saw me and cared about me, but I think I was too far gone to, it's like, thanks, I'm fine, was my reaction.
What, and just, cut me off if something gets too personal, but presumably you were making good grades because you were putting all this pressure on yourself and sort of laser focused in that regard. So was your health just deteriorating, or was it like some sort of external manifestation that people could even notice, or did you just seem too focused, or how did people even notice?
My physical health was extremely poor. I'd lost a lot of weight. I developed some disordered eating. I was extremely unhealthy looking. I was very physically weak by the time it got really bad. So that led eventually to me being hospitalized in graduate school because I was extremely close to death. Physically, my
I'm sorry. Did you resist that? Being hospitalized? Like how difficult was that? And I'm sorry I interrupted. I just off the top of my head.
No worries. I kind of did and I didn't. So by the time that the university reached out to me and told me that I needed to seek care or be kicked out of the program, by that time it was so many years of living that way. I was extremely weak. I was, at the point where I had trouble physically walking. My heart was damaged. I looked like I was, about to die. And I had a lot of trouble just doing day-to-day activities. So because of that, I kind of knew I needed help, that if I didn't get it, I would probably die. So part of it was me resisting in the sense that I just wanted to continue my life the way it was. But part of me realized that my life would not continue. So when I got the message from the university that, concerned people had told them that I should seek medical care, and if I did not, I would be kicked out, my first reaction was fear and just how can I get out of this? How can I continue the way that I am?
Totally, that would be me.
And then when it's just this bizarre thought process that doesn't make sense to anybody except yourself when you're in it. And then part of me was relieved that maybe this would be over. I just knew that I couldn't continue the way that I was because of I couldn't walk. It's I'd had a fall and I wasn't able to get up. So,
wow. From dizziness or lack of strength or all of the above? Or
lack of strength. I was walking home. I didn't have any strength. I fell in a field. I yelled for help and a lot of people walked by and one person stopped and carried me home. So that was a low point. And I knew something had to change. So I was relieved, maybe as much as I was, sad and scared. So I ended up going to the hospital where I was hospitalized for 6 weeks, part of that on a cardiac ward because my heart wasn't. So when you're starving, your body tries to use whatever energy source it needs.
And that means harder work on the heart because it's it's pumping blood, asking for more nutrients or something. Sorry, I'm ignorant.
I think your body tries to digest whatever sources of energy it has left.
I see, including
the heart.
Yeah. Okay.
So I was actually very close to death.
So were you on an IV? Sorry.
Oh yeah. Oh, I was on everything. I was. My body just was nowhere near where it needed to be. I was on all kinds of IVs. electrolytes were just horribly imbalanced. I had liver problems, I had heart problems, I had osteoporosis, I had everything that you could think of. I was, 21.
Should be in great health.
So I was, yeah. But yeah, I was under careful care for a long time because I was quite close to death. I remember that my heart rate was really high. So my resting heart rate was, I don't know, maybe 120.
Whoa.
And I'd brush my teeth in the morning. And when I'd get up to brush my teeth, my heart rate would go up to 160, 180. The alarms would go off. The nurses would come running in to see if I'm okay. And I'm just standing there brushing my teeth, So there was a lot of recovery that had to occur over those 6 weeks.
And so it's six weeks, and then did you go immediately back to graduate school? How's that process getting back in to graduate school and the flow of things and just moving forward?
So probably wouldn't surprise people to know that I was analyzing data while I was in the hospital. Of course, yeah. And that sounds terrible, but I needed something.
You gotta have something, yeah.
And I did a lot of reading. I read novels. I tried to, relax as much as I could, but I also needed to forget my situation sometimes. And I love brains and memory and data. And it wasn't that I felt pressured. It was I needed to do something. But I did take a good chunk of time. I was away, not just the rest of the quarter, but also a good chunk of the summer. Did a lot of time to try to build hobbies and find my friend groups and so on. And then was back. This happened about in April, and so I was back in graduate school at the end of September.
And this, your personal experiences must have had a lasting effect and continuing effect on how you run your lab and probably your sensitivity to students' needs, I would imagine. Would you say that, stupid question, but has that had a large effect on just, how you run your lab and how you take care of your own self these days and the memory for that and mindfulness of that? Is that a constant sort of inner reflection?
Yeah, that experience was so awful for me, as you'd imagine. It was not just the hospital, but everything before that. The memory of that, for some people it sounds like, oh, that was, more than 10 years ago. It's old. You're probably fine now, but
right.
That doesn't go away.
Right.
So that the unpleasantness of those experiences is something that is still very difficult for me to talk about, and is a good reminder for me to never go back to that place again. So as negative as those memories are, they are a very powerful deterrent for ever returning to that place. And I'm a lot better now at leaning on my partner and my family and my social support group so that I don't return to that place. And I hope that has made me a better mentor and more aware of people's needs and the importance of mental health and self-care. I'm very open in talking about it, and I try to be supportive of people. I've had some moments that I'm not proud of, especially when I was early in my assistant professor career, where there's so much pressure.
Oh, so much
to produce.
Yeah. I remember seeing people like running, new faculty members sweating and running through the hallway it just seems so high pressured. And so that has got to be the worst situation for someone who's gone through something like you have to be in. Let me throw myself into this even harder, more pressure situation.
Yeah. And I think what I'm not proud of is that I let the pressure that I feel kind of leak over to my trainees, where in hindsight, I should have been easier on them. I should have given more time and less pressure. And that's one of my biggest regrets is I think that the pressure to produce should have been something that was on me and contained enough that I didn't, that I respected my trainees' needs for mental health time a little bit more. I'm better at it now, both because I realized that my past self was maybe putting a little bit too much pressure on my trainees. And also because the further you go in your career, the more you kind of like let up. It's like, okay, I got that paper out, I got that grant. Maybe I can relax a little bit more.
You kind of see that over the long haul, it's a marathon, not a sprint or something. Is that but how do you get around feeling like it is a sprint in the beginning though, right?
It kind of is. Those first few years, I think there's just so much pressure to write all the grants, write all the papers, like get the data from your labs, just get going. And I just don't know how to take away some of that pressure.
How's the tenure going? Are you tenure tracked yet?
I'm not tenured yet.
Okay.
So that's coming up in the next couple of years. I'm at the point where, I know I've been trying my best. And that if that's not good enough, then I've at least gave it all I got. And I'm not willing to give any more than I have. So hopefully it's enough.
We talked about you not knowing what psychology was early on. And of course, I didn't know what neuroscience was early on. And I'm pretty sure when I got into graduate school, I didn't know what tenure was. So I was like so naive about academia. And I suppose I still am.
I am too. I didn't really understand the difference between assistant, associate, and full.
I still don't.
Until I started my faculty job.
There you go. Yeah.
Yeah, I had a lot of learning to do as well. There's a lot about academia that I didn't understand.
Yeah, I wish I had something more comforting, more profound to say. I really appreciate you sharing your personal experience. This is not something that we usually talk about or go into that much depth on the podcast. So I really appreciate that. I'm sure it's probably becoming more easy to talk about, but I'm sure still difficult to talk about. I don't know if congratulations is the right word, but I'm just happy that you're continuing to move in the right direction, I hope. And I'm glad that you came out of it and sorry that you had to go through that.
Yeah, I hope just by talking about it that it'll help other people who might be in similar situations and maybe prevent people from living what I had to live through. So it's not something that's easy for me to talk about. There's a lot of details I'm not sharing, but hopefully in at least providing this part of my story, I can try to help others.
Even knowing probably that there are experiences like yours, someone who may be suffering through a similar experience, even that has got to be just a shining light of hope, I would imagine.
So when I first shared this story, like you mentioned, I wrote about it briefly at Stories in Science, and the outpouring of support and thanks I got was, it was very touching. And it felt like maybe one of the most important things that I'd ever done. So, I've come to think that, my research is fine and some people like it. Some people probably don't. But I think I'll probably have a bigger impact in other areas. And I think one of those is trying to be more open about mental health struggles and the fact that many people experience them. They're nothing to be ashamed of. It's not something you can think yourself out of. That when you're in it, it's very difficult to get out. And I think it's not, one person out of 100. It's a lot of people. In a group of 10, probably half might have had some mental health struggles. So I do think it's important to talk about these things. And I received a lot of support for sharing some of my story, and a lot of people, I hope, were helped by it and will continue to be helped by it.
Well, I appreciate you being so open about it. So thanks. All right, Mariam, I've taken you long enough. I really appreciate you sharing so much of your personal story with me, but then also congratulations and continued success on the science story as well. And I feel very optimistic for your future science path, because there seem to be many open questions to continue to tackle.
Thanks so much. It was a real pleasure, and thank you for giving me the chance to not just talk about science, but also talk about mental health.
I alone produce Brain Inspired. If you value this podcast, consider supporting it through Patreon to access full versions of all the episodes and to join our Discord community. Or if you want to learn more about the intersection of neuroscience and AI, consider signing up for my online course, Neuro AI, The Quest to Explain Intelligence. Go to braininspired.co to learn more. To get in touch with me, email paul@braininspired.co. You're hearing music by The New Year. Find them at thenewyear.net. Thank you for your support. See you next time.